Hello, class, and welcome to the part 2 of the final exam review. And the first question I have for this one should be a more short answer based one. This is the distribution of ACT scores for high school students in the United States is normally distributed with a mean of 29 and a standard deviation of 4. We want to fill out the following normal distribution based on the empirical rule. We want exact values, so none of this rounding mamma jamma stuff. So based on this, we have a mean of 29, a standard deviation of 4. And if we recall correctly, we have that 68% of our data is within that one standard deviation. So in our case, that will be 29 plus and minus just one standard deviation would be 4. This would give us values of 25. And on the higher end, that would be 33. Then for the 95% of the data, that's the 2 standard deviations. This is 29 plus and minus 2 times 4, or 8. So this will give us 21 to 37. And then the 99.7% is within 29 plus and minus 3 times 4, or 12. So this then would be between 17 to 41. And then we just need to label what all these parts are. A being this third standard deviation on the smaller side. A here would be 17. B being here would be 21. C here would be 25. D, which is right in the middle, is going to be our mean of 29. E is going to be 33. F, right here, is going to be 37. G here is going to be 41. H, which is this first standard deviation, we are given this is 98% of the data, 68% of the data. So that's 68%. So now for I, J, and K. These ones require a little bit of math. I, J, and K. Okay, so I said that from here to here, that's 95% of the data. We know that this is 68 here. So this portion right here would be 34%. And if we took half of this 95, this would give us 47.5. And if we subtract 34, we should get what this I here is. And this would give us 13.5%, which is going to be our value for I. Again, same idea here for J, from where A here is all the way over to where G is. This is supposed to be that 99.7%. I'll label that right here. Right, so we know this is 34% right here. This part right here we just said was 13.5. So to find what J is, which would be the same as this one over here, we are going to take, in this particular case, half of 99.7%. We are going to subtract these other two that we have, 34 and 13.5. So from that, we would get an answer here of 2.35 as a percentage for J. And then finally for K, since this entire portion, and I might as well just label it here so I am consistent. Let me just make that 5 a bit more legible. There we go. So for that value of K, which is this small little sliver here, we know all this side here has to add up to be 50%. Yes. So if we take 50 and subtract all of these values, we get this very last one. That means K here is supposed to be 0.15% to get that last value. Alrighty, moving on to question number 2. We have, you must pick one of 2 wagers for an outcome based on flipping a fair coin. Wager 1 is you would win $540 if it comes up heads and lose $120 if it comes up tails. Wager 2 is if you would win $630 if it comes up heads and lose $210 if it comes up tails. We want the expected outcome of each wager, which is better, and explain why. So our expected value or the mean for wager 1 is 540 times a half minus 120 times a half. This gives us 210. The second wager, expected value or the mean, 630 times a half minus 210 times a half. And this makes 210. In this particular case, both are the same. Is that necessarily always the case? Of course not. But in this case, it is. So we still have to answer this. Both of these expected gains are the same. Both expected gains are the same. What does that mean? That means both wages are good. Right? Both of them made that $210, so we're good with that. Moving along. I have question number 3 here. At the menu tab output. Shown is the result of a regression analysis for 29 homes, relating Y is the selling price in dollars to X the size of the house in square feet. We want to use the 5% level of significance. Include the following in your answer: hypothesis statements for A, B, the test statistic rounded to 3 digits, C, the p-value also rounded to 3 digits, and the conclusion, written as an interpretation based on this lovely looking output. Okay, so this hypothesis test is going to be that the null hypothesis is our slope for the line of best fit here is 0, or that we do not have a linear relationship. The alternative is that the slope is non-zero to denote a linear relationship. Part B wants that test statistic, which in our output is going to be this value here. So T would be equal to 8.916. C wants the p-value. That one is over here. Just 0. So that's helpful. 0.000. Always a good thing when it's a nice number like that. And then for part D, we wanted the conclusion. So this would be at the 5% level of significance. we have evidence because the level of significance is greater than our p-value. So we have evidence. To support that selling price and size. Selling price and home size have a significant linear relationship, which we could see in this output I have here on the screen. And then I have one more page of this. Number 4, I have this lovely looking data set. And we want to decide based on this information in the table, which on Blackboard is listed as the interest data set, whether students' interest in statistics is independent of their ability in mathematics, using a level of significance of 0.01. We want the null hypothesis. So this is going to be the interest in statistics and ability in mathematics. Are independent. The alternative is going to be the interest in statistics and ability in mathematics. Are dependent. Or you could say associated. Both would be that same idea. Part C, we want the chi-squared test statistic rounded to 3 decimal places. So we need to take this data set and paste it into our Excel template. So let me first open up the data set, that being this one. I want to take it, copy it, and then open up a chi-squared chi-squared template. So we can actually go about calculating this, that being this. Then it's going to paste our data in here. And it should go right in. So for our chi-squared test statistic, we have here a 45.99 as our value. Let me write that down. Chi-squared test statistic is 45.99. We also wanted the p-value. Now you might have noticed something. Let me go back to it. It says a number here. And we could see that it claims there to be an issue with the formula. There actually would not be an issue with this formula, since the formula is actually correct for it. The problem for this is, since this chi-squared test statistic is so big, our p-value is essentially 0. So p-value here is going to be just 0, since our test statistic is very large. There's 0 in this particular case. What's the decision we're going to make? We are going to reject the null hypothesis, since that p-value is very small. And then what conclusion or interpretation can we make based on that? Well, this is going to be at that 1% level of significance. significance. We have evidence. To suggest that interest in statistics and ability in mathematics are dependent or associated. All right, that's our second part of this final exam review. Let me know if you have any questions or concerns, and good luck on the final. Thank you.